Okay, so this is my 03 Subaru Forester, and I haven't put the lithium battery in it. It's been idling here for a couple minutes, and as we can see, we're running 14.44 volts on the battery. So the alternator is charging and sitting at right about 14.4 volts. Turn it off. Now we should see our voltage drop to something less than that. It's 12.67, 12.66, okay. So as you can see, we shut our voltage alternator off and the voltage drops to about what lead acid does. Now I'm gonna go swap the battery. Okay, so now I've swapped in my custom lithium battery. It's got that Daly BMS, car start BMS, 150 amp, like continuous, and 75 amp hour cells. So this is the other phone with the app running, and as we can see, we've got a SumVolt 13.3. Doesn't know what capacity it is. Charge bus and discharge bus are both on, and we can see our various voltages here. 3.29 volts per cell to 3.25, and it's showing a 13.3 volt. If I take my multimeter and hook it on, let's see if we can do this all in one. Okay, 3.26 volts, and we're seeing 3.3. So within realm of you know, slight variation there, or rounding. So I'm going to go in and fire it up. Fires right up. And now we can see our SumVolt 13.7 coming up. Come on. 13.8. 40 amps charging. 13.9. Charging pretty good here at idle. Alternator's warm, but not like super hot. 14.0. So this battery's pretty much charged. I expect that it's gonna hit that over voltage cutoff pretty soon. I've got it set at 3.55 volts per cell. (14.1), 3.52. Come on, stay focused. Still charging at 32 amps. Let's see if I crank this up. Doesn't really change the current much. Looks like the alternator is able to put it out at idle. I'm gonna keep that voltage up until it cuts out. Getting close to that 3.55. Oh, cell high level 2. And notice how charge MOSFET is disconnected. Now, some volts at 13.7, 13.6, it's dropping. And if we look at our actual terminal voltage, let me rev it up a little bit so we can get more than just idle here. Okay, so so there, we're at 13.7, jumping all over the place because there's no load on the battery. So here we go, we're getting 14 volts out of the alternator, but this is still showing 13.5. It's disconnected that charge MOSFET because it's gotten the full charge. Now, but the discharge MOSFET's still connected, which means when I shut the car off, I'm not going to lose everything. See, all the lights still came on. Now I turn the key on, put some load on it, and now I'm seeing 13.2 volts, negative 20, and you can see how the charge MOSFETs come back on because the voltage dropped a bit. And so now we've got 13.06 volts here, 13.1. Fire it up again. Okay, clutch in. Okay, charge and discharge. We're charging at 30 amps. I want to make sure that it doesn't idle too low. So 13.69. $14, $13.9, yep, we're holding there. Come on, update. Still charging. 5.47. We're looking for 3.55. Getting close there. And there, kicks off. Now you can see the alternator voltage spikes and jumps around a little bit because there's not much load on it. And that's the one thing that I am going to have to come up with is a capacitor bank to even out when the battery's disconnected. But it's not just going to keep charging that battery indefinitely. See that charge MOSFET being disabled and the current 0 amps? So I can rev this up as much as I want. Now the voltages are still disconnected. So that's what I mean about once you hit the limit, it will disconnect the batteries. And that's good and bad. It's good it's not going to overcharge it and keep charging it as long as the key's on. And as soon as you shut it off and restart it, it'll charge itself back up to full or to whatever point you decide is full. I figure I should show you the parameter settings here. So under parameter settings, I know 3.65 is normally what you'd see, and it would work the same way, but I thought 3.55 would be a little bit closer thing. But you could set what you want as far as these settings go. But there, I thought I'd show you all that. Thank you.